Alright, so in this problem, I have a to the power of x plus 2 to the power of x is equal to 130. So to solve this, I'm going to first start by rewriting a as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x plus 2 to the power of x is equal to 130. And I can actually switch the places of 3 and x. So this is the same thing as 2 to the power of x to the power of 3 plus 2 to the power of x is equal to 130. Now I'm going to let 2 to the power of x equal to the variable y. So now I have y to the power of 3 plus y is equal to 130. Now I'm going to subtract 130 on both sides. These two cancel out. So now I have y to the power of 3 plus y minus 130 is equal to 0. Now I'm going to rewrite y here as negative 25y plus 26y. Now I have this minus 130 is equal to 0. And now y to the power of 3 minus 25y, the greatest common factor is y. So I get y times y squared minus 25 plus 26, y minus 130, the greatest common factor is 26, so I get 26 times y minus 5 is equal to 0. And y squared minus 25, that's the same thing as y plus 5 times y minus 5. And now if I factor out y minus 5, I get y minus 5 times y times y plus 5 plus 26 is equal to 0. So now this gives me two equations. I have y minus 5 is equal to 0, which means y equals 5, and I have y squared plus 5y plus 26 is equal to 0. And to solve this, we actually have to use the quadratic formula, and I'm not going to waste your guys' time by doing it, but if you do end up doing it, it actually won't work because you get the square root of a negative number, and you can't take the square root of a negative number. So we are left with y equals 5, and remember how we let 2 to the power of x equal to y. So this means that 2 to the power of x is equal to 5. And I'm going to take the log on both sides to solve this, so I have log 2 to the power of x is equal to log 5. And if I have something in the form log a to the power of b, I can move this exponent to the front, so it's going to equal b times log a. So this is the same thing as x times log 2 is equal to log 5, meaning x is equal to log 5 over log 2. Alright, so in this problem, I have x to the power of 6 is equal to x minus 1 to the power of 6. So I'm going to first start by subtracting x minus 1 to the power of 6 on both sides. So then these two cancel out, and now I have x to the power of 6 minus x minus 1 to the power of 6 is equal to 0. Now x to the power of 6 is the same thing as x to the power of 3 to the power of 2, and x minus 1 to the power of 6 is the same thing as x minus 1 to the power of 3 to the power of 2. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So this is going to equal x to the power of 3 plus x minus 1 to the power of 3 times x to the power of 3 minus x minus 1 to the power of 3, which is equal to 0. Now if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So this is going to equal k plus k minus 1 times k squared minus k times k minus 1 plus k minus 1 squared. Sorry, this is actually supposed to be x, but yeah. So this simplifies to 2x minus 1 times x squared minus x plus 1 times 3x squared minus 3x plus 1 is equal to 0. Because we also added in, remember, we also have x to the power of 3 plus x minus 1 to the power of 3. So now this gives me three different equations. I have 2x minus 1 is equal to 0, meaning x is equal to 1/2. I have x squared minus x plus 1 is equal to 0. And I have 3x squared minus 3x plus 1 is equal to 0. So for x squared minus x plus 1 equals 0, we have x is equal to 1 plus or minus the square root of 3I over 2. And finally, for this, we have 3 plus or minus the square root of 3I over 6. Alright, so in this problem, I have 11 to the power of 9x plus 11 is equal to 9 to the power of 11. So to solve this problem, I'm going to first start by taking the log on both sides. So I have log 11 to the power of 9x plus 11 is equal to log 9 to the power of 11. Now if I have something in the form log a to the power of b, I can move b to the front. So this is the same thing as b times log a. So log 11 to the power of 9x plus 11, I can move 9x plus 11 to the front. And log 9 to the power of 11, I can move 11 to the front. So now I have 9x plus 11 times log 11 is equal to 11 times log 9. Now I'm going to divide both sides by log 11. So then these two cancel out, and now I have 9x plus 11 is equal to 11 times log 9 over log 11. Now, log 9 is equal to 0.9542, and log 11 is equal to 414. So now I have 9x plus 11 is equal to 11 times 0.9542 over 1.0414. And this is the same thing as 11 times 0.9163, which is equal to 10.0789. So now I'm going to subtract 11 on both sides. So I get 9x is equal to negative 0.9211. Now if I divide both sides by 9, I get x is equal to negative 0.1023. So this is my answer to this problem.